in a sampling a large number of a large number of parts manufactured by a company. The mean number of defectives in samples of 20 is 2. In samples of 20 is 2. Out of 1000 such samples, how many would be expected to contain at least 3 defective parts? This is the question. Yes, here if you all see that I have underlined for the mean. So here they have given the mean value. Mean in the binomial distribution formula is NP. That is equal to, here they have given defective in samples of 20 is 2. So mean value is 2. Samples of 20, that we can write it as a n is equal to 20. Next, 20p is equal to 2. I am substituting in the place of n 20, p is equal to 2. So p is equal to 1 by 10, that is equal to 0.9. Now q is equal to 1 minus p. So 1 minus 0.1 is 0.9. So let us take x be the defective part. So I write let x be the defective part. So write the formula. P of x is equal to ncx p power x q power n minus x. Here n is 20, c x, p value is 0.1 whole power x, q value is 0.9 whole power 20 minus x. So here we can see how many would be expected contain at least 3 defective parts. So at least 3 defective means P of at least 3 defective parts. 3 defective parts, that is equal to 1 minus P of 0 plus P of 1 plus P of 2. This is the formula for the at least. So 1 minus here 20C0 x value for the first term, 0.1 whole power 0, 0.9 whole power 20 minus 0 plus 20C1 x value is 1, 0.1 whole power 1, 0.9 20 minus 1 plus last one 20C2 0.2 1 whole power 2. Again 0.9 whole power 20 minus 2. Here 0.3230. After solving all this term, we get the value 0.3230. Here, one more thing they asked, out of 1000 such samples. So we have to find out for the 1000 such samples. So for 20, we got 0.3230. What about for the 1000? So here we can write, thus the number of defectives, thus the number of defectives in thousand in thousand samples is 1000 into 0.3230. So for 20 we got the probability in the 3 defective parts means 0.3230. What about for 1000? 323. Here 4 coins are tossed 100 times. 4 coins are tossed 100 times and the following results were obtained Fit a binomial distribution for the data and calculate the theoretical frequencies and calculate the theoretical frequencies. Here this is little bit different. Here they will give in the term of table, but they will ask here whether it is which distribution. Here clearly they have mentioned it is a binomial distribution. So first number of heads, second one frequency. Here I will write 0, 1, 2, 3, 4, 5, 29, 36, 25, 5. Now we have to solve a problem for this type if they mention in the form of table. So for here we have mean. We can consider mean as a sum of number of heads into frequencies. Number of heads into frequencies. Number of heads we can write in the form of x and frequencies we can write in the form of f. So sum of frequencies into x. Next, divided by sum of frequency. So here 0 into 5, 0. 1 into 29, 29. 2 into 36, 72. 3 into 25, 75. 4 into 5, 20. Summation 5 plus 5, 10. Next 35. If you add these two, overall we get 100. So what is the numerator term here when you add?
196.
Yes, 196. So 196 divided by 100 is 0.96. This is the mean. But we know our mean value in the binomial distribution formula. Mu is equal to n into p. Here they have given n is equal to 4 because 4 coins are tossed 100 times. So that implies mu value is 1.96, that is equal to n value is 4 into p. That implies p is equal to 1.96 divided by 4. What is the value?
0.49.
0.49. Once we find the p, we will go to the q. Q is equal to 1 minus p. So 1 minus 0.49 is equal to
0.51.
0.51. Now we write the binomial distribution probability function, that is p of x is equal to ncx p power x q power n minus x. N value is 4, c x, p value is 0.49 x, q value is 0.51, 4 minus x. But in the question they have given 4 coins were tossed 100 times. So that we can expected frequency. So theoretical frequency, expected frequency, both are same. So we can write expected frequencies is equal to capital F of x. That is equal to 4 coins were tossed 100 times, means 100 into, we can write binomial distribution probability function p of x, 100 times into probability function. So 100 into 4cx 0.49 whole power x 0.51 whole power 4 minus x. Now we have to find the expected frequencies. How we have to find? First value of x is 0. So we give x is equal to 0. So 100 4c 0 0.49 whole power 0 0.51 4 minus 0. We have to find the value for this one. Next value of x is f of 1. So 100 into 4c1 0.49 whole power 1 0.51 whole power 4 minus 1. Next value f of 2. 100 4c2 0.49 whole square into 0.51 whole power 4 minus 2. Next value is f of 3. 100 4c3 0.49 whole power 3 0.51 4 minus 3. Last one f of 4. 100 4c4 0.49 whole power 4 0.51 4 minus 4. 6.7652. You can write approximate value as a 7. 55.99. We can write this one as a 26. 37.47. So approximately we can write it as a 37. Yes, so approximately we can write it as a 24. 5.7648. So we can write it as a 6. So therefore expected frequencies are expected frequencies are 7, 26, 37, 24, 6. This is 5 dice were thrown. 5 dice were thrown. 5 dice were thrown 96 times. 5 dice were thrown 96 times. Yes, 5 dice were thrown 96 times, and the number of times an odd number actually turned out in the experiment is given. Fit a binomial distribution. Fit a binomial distribution to this data and calculate the expected frequencies. Calculate the expected frequencies. So here they have given number of dice showing 1 or 3 or 5, because in the dice we can find the odd numbers are 1, 3 and 5. Here observed frequency. Here I will write 0, 1, 2, 3, 4, 5. Values 1, 10, 24, 35, 18 and 8. This is the question. Now already they have given the odd numbers 1, 3 or 5. So P is equal to number of odd number in a dice is 3 divided by total number of numbers in a dice is 6. So P value we get 1 by 2. Next, Q is equal to 1 minus P is equal to 1 minus 1 by 2, that is equal to 1 by 2. Now we have to find the binomial distribution probability function, that is P of x is equal to NCX p power x q power n minus x. Here n they have given 5 because 5 dice were thrown 96 times. So n is equal to 5. Now 5cx p value is 1 by 2 whole power x. Next q value again 1 by 2 n minus x. So further simplification we can do here 5cx. When base are same we can add or subtract the power. So 1 by 2 x plus n minus x. X will get cancelled. So 5cx 1 by 2 whole power n. This is the p of x value. Now we have to find the expected frequency. So here we can write consider expected frequency, that is f of x is equal to how many times? 96 times into p of x. So here 96 into 5cx 1 by 2 into n value is 5. So 96 divided by, what is the 2 power 5 value? 2 power 5.
32.
Yes. So here 2 power 5. Instead of 2 power 5, we can write 32 into 5cx. So here 32 3s are 96. So we can write 3 into 5cx. Now we have to give the values for x. So we have to start from 0 because starting value of x is 0. So f of 0 is equal to 3 into 5c0. F of 1 is equal to 3 into 5c1. F of 2 is equal to 3 into 5c2. Next, here f of 3 into 5c3. F of 4 3 into 5c4. Last one f of 5, that is 3 into 5c5. Yes, for f of 0 we get 3. Then for f of 1 we will get 15. Again for f f of 4 15, and for the last one f of 5 is 3. Therefore we can write expected frequencies are expected frequencies are 3, 15, 30, 30, 15, 3.